Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to greet my supervisor, Dr. Siti Ferus binti Ahmad Faisal, and my examiner, Madam Azlin binti Dahlan. My name is Marshadana binti Salihuddin from the group CS 2306A. Today, I'm going to present my final project presentation FYP. The title is Learning Radioactive Topics Using Augmented Reality. So, I would like to begin with my first point, the background of the project. My project is focused on an education which is radioactive topics, where this topic is under physics. As we all know, physics is a compulsory subject for student science streams to sit their SPM examination. Therefore, the project learning that includes AR is developed for students from 5 to make students have fun and understand that topic. Next, from my findings on a survey, I have looked up that there are 3 problem statements. Firstly, the students think that learning physics is difficult. The second is, the students think that learning physics using textbooks only is less enjoyable. And lastly, the students said the explanation offered in the textbook sometimes confusing. Next, for the proposed solution, I have decided to make learning using graphic with a suitable music background, include the interesting features such as having a colorful text, and include augmented reality features. So, these are the examples of augmented reality features that are already being tested in mobile application. The first one is a smoke alarm model that explains about the application in real life by using alpha radiation. The second one is an example of fertilization that can be used for a plant, and it explains about the application in real life by using beta radiation. Next, a displaying heart model is also an example for the application in real life by using gamma radiation. Lastly, the dice is for using the explanation in real life about half-life so that the students can understand more. I have 2 techniques to implement the project system such as making AR. The first one is hardware. The edition is Windows 10. The processor Intel is Core i5 and the install RAM is 12GB. And the system type is 64-bit operating system. For the software, I have using 3 tools, which are Adobe Photoshop CS6 to edit the text and graphic. Second is Microsoft PowerPoint to edit the picture. And lastly, Software Unity version 2020 to make a full system, plus Vuforia engine in Unity is for building the AR model. Let's move on to the next slide. A flowchart will explain the system flow. For the user, they can go to the info button if they want to. For the quiz button, they will directly go to the quizzes website once the button is clicked. Then the users go to the play button and it will display 3 categories of radioactive topics. For the first category, which is type of radiation, the user will learn about the characteristic of 3 radiations in a colorful text to make them easily remember the terms available. Then the user has the option to continue or return to the main menu. The second category is application of radiation. The focus will be on the graphic with augmented reality. It will describe how the radiation will apply in a real life. The user must scan the AR picture in order to see it in 3D. Aside from that, it includes a video on decay radiation. The user can enjoy learning by watching video. Then, the user has the option to continue or return to the main menu. The last category is decay graph. It provides a little bit of the information and delivers one type of AR about half-life by clicking the View AR button. A good explanation from background sound will be given so that the user will have a better understanding. Next, I will present a project demo in the next slide.
Reputan alfa berlaku apabila suatu unsur radioaktif itu mereput dan membebaskan zarah alfa dalam bentuk nukleus helium. Atom X merupakan contoh nukleus yang tidak stabil. Untuk menjadi stabil, ia mereput menjadi atom Y dan pada masa yang sama membebaskan zarah alfa atau nukleus helium. Jika X mewakili uranium dan Y mewakili thorium, perubahan dalam nombor nukleon dan nombor proton boleh digambarkan dalam contoh persamaan berikut. Jika kita amati persamaan tersebut, nombor nukleon uranium 238 ditolak dengan 4 unit, manakala nombor proton 92 ditolak dengan 2 unit untuk menghasilkan thorium dan nukleus helium. Persamaan berikut adalah contoh yang mewakili reputan beta. Proses ini tidak mengubah nombor nukleon dan nombor proton nukleus yang terlibat. Sebagai contoh, maka kita hanya menulis simbol gamma di dalam persamaan tersebut bagi menunjukkan berlakunya proses reputan gamma.
Americium isotopes that release alpha particles are employed in smoke alarm. The air is ionized by alpha radiation, allowing a tiny current to pass between two electrodes. Smoke stops alpha from entering, the current lowers, and the alarm goes off. The isotope should have a lengthy half-life and be an alpha emitter. This eliminates the need to replace the smoke alarm on a daily basis. The type of radioisotope used in agriculture is phosphorus-32. It has a half-life of 14 days. Phosphorus-32 is used as a tracer in the study of the effectiveness of fertilizers. Moreover, the plants are watered with a solution containing phosphorus-32. The type of radioisotope used in medicine is technetium-99. It has a half-life of 6 days and is used to study of the blood in the heart. It emits only gamma rays and produces no harmful alphas or betas inside the body. In one class there are 20 people, then divide into 5 groups. Each group is supplied with 60 dice. Each dice represents one radioactive nucleus. Roll 60 dice on the table. Remove the dice that show the number 3 because the dice that show the number 3 just now represent a nucleus that has decayed and represents the activity of the radioactive sample. Then, record the number of dice remaining because the remaining dice are considered as undecomposed nucleus. Toss again the remaining dice on the table and remove the dice showing the number 3. Record again the remaining dice. Repeat the previous step 20 times.
For conclusion and future work, the game-based learning is a new educational platform and medium for students to get educational knowledge. Despite the fact that this medium is unusual for delivering educational content, research has shown that game-based learning is a revolutionary tool for educating students. As a result, a game-based learning system for radioactive topics was developed and delivered to the target audience of Form 5 students in order to improve their knowledge and experience by using augmented reality. For future work, the system will include other languages, such as Malay, to promote this learning to people who don't speak or understand English well. Second, instead of being limited to Android users, the radioactive topics application might be improved by creating for other mobile platforms such as iOS and Windows. Finally, more topics from their school textbooks can be added to this application in the future, along with various types of game-based learning that are more appealing and fascinating in order to provide a deeper grasp of physics. So that's all from me, and thank you.